for example, the distance between this main point here, which is the average delivery time, right? 60. The distance between this bar and the first bar you can see here on the normal distribution is what we're going to call the standard deviation. So basically you do that stretch and you go, okay, so 60 to 90, that's 30 minutes. Well, then half of that, right, is probably going to be 15. So we know that the standard deviation here is 15 minutes. Cool. And this is what the thing that's going to tell us the stretch of our distribution. On the other hand, we have the mean. The mean is the 60 minutes, which is the thing that's going to tell us about where the center of this distribution is. So why am I saying that? Because you can build any normal distribution from only two stats, mean and standard deviation. So how do we do that? Let's say we don't know, the delivery time for our pizza. Well, how do we do that? Well, we know that the mean is 60. The standard deviation is 15. Now let's get rid of this distribution altogether. Let's build it from scratch, okay? So this is how we got before. Let's get rid of it. Let's pretend we never saw this distribution. Let's start from the mean. So the mean is 60, so let's set the mean there. Let's set the mean as the center of this normal distribution, okay? Now, the standard deviation is 15 minutes. So we can plug that 15 minutes back to the distribution and say, okay, so this is 60 minutes, so plus 1 standard deviation, right? The distance between this and that is 75. So plus 15, because this is symmetric. I don't know if you can see this is symmetric. Plus 15, that's going to be 90 minutes. And then 60 minus 15, it's also symmetric. They're all the same length. I hope you see that. Like the distance between this and this, this and this, this and this, they're all the same. So minus 15 is 45. And then we have finally our 30. And then finally, we have our two standard deviations above and below the mean. Why do I see two standard deviations? Because it's literally 2 times the standard deviation, which is 15, right? So 60 plus 15 is 75. That's 1 standard deviation. 75 plus 15, that's 90. That's 2 standard deviations. So this is 2 standard deviations above the mean. Hopefully now you understand a little bit of what the language of 1 standard deviation above and below the mean means. But most importantly, now we have these bars here. And these bars are going to be telling us about 95% of the value. So these red bars that you see here. So we know that 95% of the deliveries range between 30 minutes and 90 minutes in delivery time. Okay? And it's great. And we love that. And now when we put the data back in, you can see that, from what was just a piece of data that we had before, just that old histogram, now we have like an entire distribution put together. Yeah, so this is great. Cool. And now we can also compare ourselves to the rest of the population. So how do we do that? Well, if you have time in your hands, you can go to this link and you can find your big 5 personality traits. So these are personality traits, very scientific, that also organize themselves in a normal distribution. So for example, what are the chances of meeting someone with a level of extroversion above 84%? Right? So if extroversion organizes itself in a normal distribution, and you are a person like me that's highly extroverted, right, with an extroversion of 84%, what are the chances that you're going to meet someone with a level of extroversion above 84%? Well, it's pretty easy. Well, you find the difference, right? What's 100 minus 84%? Well, that's probably going to be 15% something, 15.9%, right? Because 15.9% is 100 minus 84.1. That's 15.9%. Cool. So like this range of the distribution, these are going to be people with higher levels of extroversion than this person with a score of 84 in the 84th percentile